Oh, hello again, calculus friends. Let's continue our journey through derivatives. And today, our topic is called the mean value theorem. And we know these words a little bit in terms of we know mean is just another word for average, and that's exactly what it is in this case. So the first thing we're going to do is we're going to define the mean value theorem. And this is one of those instances where I'm going to write like a whole bunch of math gibberish, and then we're going to go back and we're going to break this apart, and we're going to take care of understanding all of these pieces. All right, so we have if f is continuous on closed interval AB and differentiable on the open interval AB with an open ends, then there exists a number C in AB such that f prime of C is equal to f of B minus f of A all over B minus A. Okay, lots going on there. Let's talk about what we're looking at there. So first of all, it says if f is continuous. We've already looked at continuity in this course. We know that means the points are defined. The limit from the left and right have to exist. The limit has to exist. And it's on a closed interval. That just means we're including A and B and everything in between A and B. And it says it's differentiable. And in terms of that, what means the definition is defined algebraically. It means graphically there's no corners. And it's on the open interval. And the reason it has to be differentiable on an open interval is because it can't be differentiable at an end point because there's no derivative from the left and derivative from the right. So it's saying given these circumstances that it's continuous and it's differentiable, then there exists a number C in AB, so C is between A and B, such that the derivative at C, which is the instantaneous rate of change at C, is equal to this right here, which is the average rate of change. That's why this is called the mean value theorem, because all it's saying is that on an interval, there is at least one point C such that the instantaneous rate of change is equal to the average rate of change. All right, let's check out what that means. Let's do a graph for that. I'm going to do that right here. I'm just going to draw a situation to depict exactly what's happening for this. So here is our graph. I'm going to say it looks like this, and I'm going to say this is like A, and let's say I'm going to put B like right there. All right, and I'm going to draw a line between those. So that's a secant line. Whenever a graph cuts a graph like that, it's called a secant line. And the slope of that secant line is this right here. So the slope of that line, how do I want to write this? I'm just going to say m for slope is equal to f of B minus f of A all over B minus A. That's the average rate of change between A and B of this function. That's the average amount of change between those. What this is saying is that if f is continuous, which I am between A and B, this is clearly continuous and differentiable. So then when I look at between A and B, are there any corners? No. Is there anywhere the derivative is undefined? No. So therefore, this is continuous and differentiable. So the mean value theorem guarantees there's at least a number C in between A and B such that the instantaneous rate of change is equal to the average rate of change. In other words, there's going to be a tangent line on here that's going to have the same rate of change as this. So if I went here, let's say right there, well, my tangent line looks like that. So that would be a bad example. That definitely doesn't have the same rate of change as this line. But if I move up here, maybe when I get to like right here, this guy has the same rate of change as this average rate of change. So this would be my point C, such that f prime of C is equal to the average rate of change. So what's the purpose of the mean value theorem? The purpose of the mean value theorem is to guarantee a value. It guarantees if it's continuous and differentiable on an interval, there exists a number C such that the instantaneous rate of change is equal to the average rate of change. And in this diagram, that C value occurs right there. It's also possible that there's multiple values beyond that interval. All right, we got to do a problem, which means I got to erase the board, which means I got to edit the video.